Hello. In this video, we want to look at the domain of rational functions. So the domain of a rational function is the set of all x values for which the function is defined. Exclude all values of x from the domain that cause the denominator to be 0. So we want to state the domain using interval notation. Now, in my math lab, it's just going to say x not equal to blah. That's fine. But for now, let's just look at it in interval notation. So basically, to find the domain, we take the denominator, in this case, x minus 4, and say that it is not equal to 0. And solve. Add 4 to both sides, so x is not equal to 4. So in my math lab, here's what you're going to do. You're going to see the set of all x such that, and then a square, and then you're going to click on that. You're going to type in the x is not equal to 4, and then there's closed curly brackets there. That is set notation. Interval notation is the following. Notice that if we were to do this on the number line, we would say everything except for 4, so it's everything to the left of 4, excluding the 4, and it's everything to the right of 4, again, excluding 4. So the domain would be negative infinity to negative 4, excluding 4, negative 4, positive 4, yeah, there we go, union, and then 4 to infinity. And there you go. That would be the domain of f of x equals negative 3 divided by x minus 4. Next, let's look at the domain of f of x equals 3x plus 1 all over x squared plus 3x plus 2. So to do this, we take the denominator, x squared plus 3x plus 2, and say that it's not equal to 0. And then you solve this. You can solve this by the quadratic formula, completing the square. My recommendation, though, is just to factor it. It's the easiest way. So 2 sets of parentheses, not equal to 0. So we have x plus 2 and x plus 1. And then set each one of these not equal to 0. And solve. So x is not equal to negative 2, and x is not equal to negative 1. So what we would see in my math lab would be the following. The set of all x such that, and then this big square bracket, and then close the curly brackets. For me, though, I prefer the following. We can use everything to the left of negative 2, excluding negative 2. Everything between negative 2 and 1, excluding both endpoints, and everything to the right of 1. So the domain here would be negative infinity to negative 2, union, negative 2 to negative 1, union, negative 1 to infinity. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.